Hello, my name is Alfredo Terrazas, and today's date is April 18, 2021. This is my submission for CIRC08 Attempt A. In this attempt, we were supposed to apply a servo to the potentiometer to control its arm, along with the addition of two extra components. In this attempt, I went ahead and set up an extra 4 components, 4 LEDs, and I set them like a power meter that will measure when the potentiometer reaches its max value and when it'll show when it's at its minimum value as well. I'll go to it in a second. Let me go ahead and start explaining the code. So at the very top, we set up the servo with the servo command and call it my servo. We set up the pin for the potentiometer to analog pin 0, and then we use the variable value to store the value from the pin, from the potentiometer, from the sensor of the potentiometer. I then set up 4 LED pins and assign them each digital pins number 3, 4, 5, and 6 individually, and all of them are set into data type integer. In the void setup, we just attach the my servo, which again is the servo, and we gave it the variable name my servo, and we attach it to pin number 9. So it's gonna be on digital pin number 9, and then I set up the other 4 pins as output. Now this is where it gets a little complicated. On the void loop code block, I set up 4 different integers, all of them called threshold number 1 through 4, which are going to measure when the threshold of a specific on the sensor, when the sensor reaches a specific threshold. I'm gonna use these 4 integers to go ahead and determine which LED will turn on and when they will turn off. We then set the value, the variable name value, to read the value from the pin on the potentiometer using the analog read command, and then we went ahead and mapped those values to match the values on the servo so that they would rotate the appropriate degree, because the servo does not read 0 to 1023, which is the value of the potentiometer. We're mapping it from 0 to 10 to 1023 to 0 to 180, which is going to be the values that the servo uses. That way they'll match up with the values of the potentiometer. And then lastly, we set up the my servo write command to go ahead and set the servo in the position of whatever the value is, which again, the value is going to be the value read from the sensor in the potentiometer. Now the next 2 blocks, so to say, is of my creation. A lot of trial and error to get this to work, but essentially I set 2 separate if else constructs, blocks, I should say, 2 different if statement blocks. The first block, which is going to be this one right here, is going to be separated by these 2 brackets, so I can force a different association from this block to this block on the bottom. Now I'm going to explain the one on the top first, because it'll directly explain the one on the bottom. So on top, we have this first block that's going to be tested. On this if statement right here, it's going to read the value from the sensor of the potentiometer using the pot pin variable name, and it'll test it against threshold 4, which is going to be the top threshold, which is set to 950. Now, technically, the potentiometer reaches to 1023, but I adjusted the values because the potentiometer is a little iffy on the breadboard and it never reaches its full 1023 value. So I adjusted both the tops and the bottom values so that they will be a little bit more concise. But it will test the value of the sensor of the potentiometer to this threshold. And if it becomes true, if this if statement becomes true, then every single statement below it will become true as well. And this will turn on all 4 LEDs. Now, if this if statement is not true, it will then jump to the next else if statement, which will then test the current value of the sensor and the potentiometer to a different threshold, which I set to threshold 3, which is going to be about halfway. And if this becomes true, then All the other pins except for the red pin, this right here is the red pin, which is the topmost pin, the pin with the highest value, it will turn every pin but the red pin on, so it'll light up 3 green LED pins but not the red one. If this else if statement does not become true, then the next one is tested, which does the same thing, but it only does it for the bottom 2 pins, and then the last one will only test the bottom pin to the minimum threshold of 65. Now, if all of these do not become true, then it jumps to the next code block right here, which is not another if code block, which has another array of if if statements, but that do the opposite, and then start out from the bottom and check out the threshold for the bottommost pin, and if it is less than the threshold for the bottomless pin, it will turn all the LEDs off. If this right here becomes true, if this if statement becomes true, all the LEDs turn off. If this one does not become true, then the next one is tested, and if this one becomes true, then all of these except for the bottommost green LED pin will turn on. And these two blocks are opposites of each other. So if this block becomes true, then this entire block cannot become true, so none of the LEDs will turn off. They will all remain on, and then so on and so forth. If this becomes true, then this one becomes true, but then the rest do not become true, so only this LED turns off while the other 3 remained on. Okay, so that was a lot of trial and error to get it to work, but let me go ahead and show it in action. On the breadboard, we have a lot of wires, so I'll try to get through them as fast as possible. We have the 3 wires that connect the power for the 5-volt and the ground to the servo via jumper cables over here. We have these 2 cables, red and black, connected to the 5-volt and ground on the breadboard. We also have 2 jumper cables over here to power the potentiometer. Potentiometer has this blue wire connected on over to analog pin 0 on the breadboard. The potentiometer is connected to digital pin 9 via this green wire, and then the 4 LEDs have their own wires connected from digital pins 3 to 6, 3, 4, 5, 6, 3 to 6, and they all each have their 560 ohm 560 ohm resistor connected to the ground on the breadboard. Now I'm gonna go ahead and show it in action. As the potentiometer moves from its lowest to its highest, the arm will move according to the mapped values, and the LEDs will turn on based on the values of the potentiometer. So everything is riding on the sensor within the potentiometer. As it goes up, the arm moves, and the LEDs turn on in order. And then once you do it in reverse, they turn off. Let me get a better angle of this. Again, my name is Alfredo Terrazas, and this is my submission for Circuit 08 Attempt A.